Now we will go through the most common European directives in the field of electronics. So the directives which are directly in our field, the most important ones are here. So the electromagnetic compatibility, the electrical safety, and radio equipment. The restriction of hazardous substances also important, not just for electronics, but also for other areas. So now we will go through all these four directives, showing what is actually stated in there and, well, what's the content. And let me just remind you that European directives are actually European law. These are not standards. Standards are showing how to make your device that it will comply with the directives. Okay. So let's start with the EMC. This is also the directive which will pay the most attention, because frankly, it is our responsibility as electrical engineer, mainly in this field, because the safety and the others directives are more or less how you choose the components, how you design the whole device also, of course, but the EMC goes straight into the development of the circuit, to every single piece of the circuit, and it's the most hard to comply with, to be frank. Okay, so the main objective of the EMC directive is just to create an acceptable electromagnetic environment. This is not the safety directive, which means it's not talking about the 5G influence to the human body, but it's talking about the coexistence of electronic devices in this electromagnetic environment. So again, to stress, it's not the safety issue here that is dealt with, and that's what you should remember. The EMC terms, electromagnetic compatibility, as talking not just about radiation of electromagnetic noise of the device to the surroundings, but also to be immune to the external radiative noise. Electromagnetic interference is the process in which the equipment is negatively influenced because of the radiation. Radio frequency is everything from 9 kilo to 400 giga. Radio frequency interference is then the noise that interferes with the other equipment in this frequency range. The electromagnetic susceptibility is how the device is sensitive to the radiated or conducted electromagnetic noise. The noise can come through the air or through the wires. And the immunity means how the equipment, the immunity means if the equipment functions properly in the presence of this electromagnetic noise. Containment means that you shield the device, that you contain in a box, in a shield, and thus protect electromagnetic noise to exit the device, or it is shielding the device from the external electromagnetic noise. Electromagnetic suppression means that you are reducing the noise by using different techniques without shielding. Shielding is covered in containment. Electrical overstress is destruction of components due to high voltage pulses. Electrostatic discharge is the high voltage pulses of non-natural origin. That means it comes from users or from other equipment that is nearby. It's not covered. So in electrical overstress we have also lightning, for example, because and here in the ESD Lighting is not included. What is equipment? Term equipment can be either apparatus or fixed installation. Okay, apparatus is something that is carried around, and fixed installation is fixed on and installed on some location. What is finished appliance? A finished appliance is something that has its own enclosure and it delivers a function. So it is a electrical apparatus, electrical tool or electrical device, machine that has a certain function and has an enclosure. So a microcontroller doesn't have an enclosure, but it delivers a function. So it's not a finished appliance. So why I'm telling you that? Because by that you will be able to distinguish electrical parts, electrical things that are within the jurisdiction of this EMC directive or they're outside. Okay, an apparatus, that's this thing here, is any finished appliance, so anything that has an enclosure and delivers a function as a single functional unit. If, and that's important, if is commercially available, is it intended for end user, and it's liable to cause electromagnetic disturbances, or it can be affected by such disturbances. Apparatus are also components or sub-assemblies if they are available on the market for self-installation. Now, let me show you a few examples, because this is quite a, how to say, legal text, and it's not very easy to understand. So, this thing here is apparatus, because it is a finished appliance, it has a function, has an enclosure, it is commercially available, you can buy it in a store, it's intended for end user, that's me, and it can cause electromagnetic noise. See here, maybe okay, it has some sparks, but I can't show any. Maybe, yeah, it generates some electric sparks in here. Okay, so that is apparatus. And this, it's a battery. This is not an apparatus. Why? It's commercially available. It's intended for end user, but it cannot cause electromagnetic disturbances because it's a battery. It delivers DC current. It cannot radiate. Now, what else? You got the picture now, right? Well, if you let me think about it. Let me see if I have something like that on the table. I got it. This is a power supply for TV. Yeah? In the meantime, we can check it is wave soldered. It's a single-sided PCB on FR1. So that's a power supply for TV. Is it an apparatus? Well, surely it doesn't have an enclosure, so it's not a finished appliance. It is not commercially available. It's not intended for end user, but it can cause electromagnetic noise, but still doesn't fall under jurisdiction of the EMC directive because it's not a finished appliance. So I hope you got the idea now. We'll have several such examples later. What about components and sub-assemblies? Are they apparatus if they are available on the market for self-installation? For example, you go to the supermarket or to a computer store and you buy yourself a graphic card. A graphic card doesn't have an enclosure. It delivers a function. So it's not a finished appliance because you plug it into a computer and then it can actually work. It cannot work by itself. But it is available on the market for self-installation. Therefore, it is under jurisdiction of the EMC directive. Okay, what else do we have? We have systems, which is a combination of several finished appliances. And if the system is available as a single functional unit, then it is called apparatus. And even though each of these sub-assemblies are compliant, you still have to do again the assessment of the compliance of the final system. A typical example is a computer. A computer, I mean the desktop computer. It contains a monitor, keyboard, it has a motherboard, power supply, hard drive, graphics card, and on and on. And it is a assembly of several finished appliances. A monitor is a finished appliance, a desktop is case, the power supply. It has a case, delivers a function. You can buy it on the market. So all that, the monitor is already certified, the graphics card is certified, the power supply is certified, but still, when you assemble it together and sell it, then you are governed by the EMC directive. Now that's strange, huh? I mean, buying computers nowadays, I mean, you can buy on the Sestavi PKC, you can buy a computer which is of several different parts and nobody then does the testing. I mean, that would be crazy, right? Therefore, if they actually sold you the computer as a final piece of machinery, as a system which would be assembled, then they would have to do that. But since they are selling you the parts and you assemble it yourself, it's your problem. And that's why they are now so only the branded computers still on the market, because they are selling as a package and they are in many quantities, so they can afford CE marking. Otherwise, I mean, in like 20 years or more ago, it wasn't so. So they were selling something, and next month another hard drive was another graphics card came on the market, and they changed it, and they didn't test for everything. And one of the reasons was also that was one of the reasons why some of these companies were not able to survive, because legally speaking, they would be all responsible to assess every assembly of these components, every PC that was different. They would have to do the measurements and assess its conformity to standards. That's quite strange, huh? From that point of view. All right. Then we have mobile and fixed installations, and fixed installations do not require CE marking. The installations which are like, I don't know, power grids, transformers, electrical, and so on, they do not require CE marking. And regarding the development of electronic devices, more or less, we should be interested in systems and in apparatus. Let us go a little bit more through the components, through the essential requirements. So in the legal documents, in the EMC directive, they do not limit to certain technical solutions. They should just say, and that's the actually copy paste from this legal document. Equipment shall be designed and manufactured regarding to the state of the art to ensure that it do not generate too much noise and it's not susceptible to that noise. So it is immune. Well, there are a lot of exceptions. So radio equipment is excluded because it's covered by another directive, which is radio equipment directive. The same stands for aeronautical products, radio equipment by amateurs, and then of course all the equipment that does not contain any electrical or electronic parts. That's normal. I mean, this table I'm sitting behind doesn't need an EMC testing, does it? Right? Or the next important, equipment, the inherent nature of its characteristics is such that they cannot generate noise, electromagnetic noise, even though it is an electrical device, or it can operate inherently without any unacceptable degradation in the presence of electromagnetic noise. So what is here? This is all called inherently benign equipment, which means equipment that cannot be harmful. The last one is custom built evaluation kits. If you make some special electronics for evaluation purposes for some institutes or research facilities, this is excluded from the EMC because that's the frontier of the research, and maybe you will be very limited if you would have to make such an equipment in the way to be compliant, right? So let me go through the inherently benign equipment. Equipment that's not dangerous in case of EMC. Cables. Cables cannot generate noise, but they conduct current. But they by themselves do not generate noise. They can act as antennas, but that's another thing. Equipment with only resistive loads without any automatic switching, such as heaters and stuff. Fans, thermostats, batteries and accumulators without active electronics, headphones, loudspeakers without amplifiers, pocket lamps without any active electronics again. If you have an LED torch that already has a switching device inside, switch mode, power supply, so it's not inherently benign. Capacitors, induction motors are just windings. Quartz watches, the very simple ones, of course, not the ones with smart features. Filament lamps, home and building switches without electronics, passive antennas, plug sockets and stuff. All the electrical, installation parts that do not have any electronics are inherently benign. So they are excluded from the EMC, which is quite obvious. Okay, so how do you then go through the process of determining whether your device is under EMC jurisdiction or not? So you start here and you say, okay, does it contain any electrical parts? No, okay, cool. I'm building a wooden desk, right? Okay, it does contain electrical parts. Okay, is it excluded by the product families? That means, is it a radio equipment or is it an aeronautical product or other listed in the previous slides? Let's say it's not. Okay, go further. Is it covered by other specific directives? No. It's not an, explosive. Maybe explosive would be covered by the explosive directives and so on. So let's say it's no. All right. Is it inherently benign? Okay, my electronic contains some microcontroller. All right, that would be probably able to radiate some noise. Okay, so it's not inherently benign. Okay, let's go further. Okay. Is it a finished appliance? Okay, What does it mean, finished appliance? It means it has a function and a case, a housing. Let's say it has a function, yeah, and it is equipped with a case. So it's a finished thing. All right. Is it intended for end user? Are you planning to sell that in supermarket? Yes. Okay, then it is apparatus. Okay, what else? Is it a component or subassembly? Is it a part? Is it Arduino? Okay, yeah. Is it intended to be incorporated into some apparatus? Yes, it is. Is it intended for end users? Is it Arduino intended for end users? Well, yes and no. It's so common nowadays that everyone is now using them. So maybe they are, and oh yeah, they are apparatus. If not, then yeah, Arduino is on the edge here. They're intended for enthusiasts and freaks and us, maybe. So yeah, they are excluded for the EMC directive. And that's a problem. That's a big problem. I will show you in some lecture later. So what else? Is it a combination of finished appliances made for commercial available, intended for end user? Yes. Okay. Apparatus. So I will skip this fixed installation stuff. And what you can do. Right. So you have apparatus. You know that it should be EMC compliant. So you should do some EMC assessment. Well, you can use EMC harmonized standards because your apparatus is covered by the standards. Maybe you are doing something so special that no standard is covering that. Maybe you are doing something that it falls into jurisdiction of maybe, I don't know, IT and communication equipment. Then you know standards for IT and communication equipment, and you take them and check them out. So if you can use harmonized standards, then you just have to show that your equipment was built according to these standards. You make technical documentation, and you are good. According to the nature of your device, you can maybe choose whether you would, or you are obliged, of course, because the thing is, if the nature of your device is such that it requires notified body, then yes, you have to go through that process. Otherwise, not. For example, if you are making a mobile phone, then you should involve notified body. Otherwise, what you can do, if you use the harmonized standards, you can do measurements of the radiation and the immunity by yourself if you have the equipment by which you can actually measure according to the standards. Or you can go to notified body and they will do it for you. Well, if you have something really special, then you might, that is not covered completely with standards, you have to do an extra checking with usually involved with some notified bodies that are saying, okay, this is something that is not yet covered. Let us think about it and let us do, and they work with you in order to get to the final verdict whether it's okay or not. But usually most of the cases of general electronics go in this direction here. So the EMC assessment, whether the device is compliant with the EMC, the apparatus I'm talking now, is sole responsibility of the manufacturer. Even though you go to the SIQ and they measure it for you, they measure the radiation for you, it's still not their responsibility for the rest of the 100,000 of the apparatus you will be producing in the next year. That's your responsibility. They are measuring that particular product and that's it. All the rest, if you're producing them, it's up to you. You have to assure that the production process and the input materials are according to that particular prototype you have been testing at the lab. When you're testing devices, you should test them in the configuration which is the most harmful, I would say, that most likely causes maximum radiation and it's maximum susceptible to disturbances. So let's say if you're measuring some electronic device, you should put such as with the software, you should put the software in the mode where it works at most, with all the communication, everything running, all the connections are there, all the external peripheral units are connected as it was in the worst case. And then you measure that one. And then you assure that all the rest cases are lower. And even though you are measuring everything, even though you checked your prototype, even though you followed all the standards, it's still not 100% sure that every device you put in the market will be compliant. Therefore, we are talking about presumption of conformity. We did everything in our powers for these devices to be conformal, to be legal, but we are not 100% sure. Okay, that's about EMC directive. Let's go to low voltage. Low voltage, well, what does it mean, low voltage directive? Low voltage is everything between 50 and 1000 volts AC and 75 and 1500 volts DC. So low voltage is not actually so low as you might think, because what we would think as a low voltage would be below 50, but that's extra low voltage. So low voltage is between, as I said, 50 and 1000 AC, and about 1000 is middle voltage, and then we are talking about high voltage. So low voltage is everything we plug it into our home AC socket. But this low voltage directive is not just talking about electrical shock because of that. It's also talking about fire, about all the mechanical issues, mechanical parts, all the danger that it's hidden in the device, not just because of electrical shock hazard, but also all the rest. Explosions, fire, high temperature, sharp edges, moving parts. So it should not endanger safety of persons and animals and environment or property. And of course, it should be designed according to the best engineering practice in safety matters. Okay, the low voltage directive does not cover some equipment which is covered by other directives, such as explosive atmosphere, radiology and medical, electrical parts for goods and passenger lifts, meters, electric fences, and so on. And at the end, we have this custom built evaluation kits, which is always such a safety when you want to build something really special that will be used in special environment with professionals to push the frontiers of technology further. Then you can make a dangerous device. All right. So what are the principal elements of these safety objectives? Essential markings. So every device that is sold on the market should have these essential markings. And this means that it should be marked in such a way that it is very clear where there are dangerous parts, like high voltage, high temperature, or anything else that is essential or good to know for this device usage. For example, do not use it outdoors if it can maybe be dangerous if it rains. It should be come in such a way that it's safely assembled with the end user. For example, you have such type of connectors that they are not interchangeable, and that you can maybe connect to the wrong socket, and that would cause a fire or explosion. It should be manufactured in such a way and designed that it ensures protection against hazards if, and that's important, if properly used and maintained. If it is used for the purpose for which it was made. And that's, you can use, I mean, a kitchen knife can be dangerous, right? But it's not prohibited. I don't know. There are many ways to use a drill, yeah? I mean, you can kill someone with it if you intend to, but that's not covered in the low voltage directive. Okay, let us go a little bit into details here. So, low voltage directive is covering electric hazards. It is also covering high temperature, burn, or radiation. This is where the 5G comes into the place. There are also non-electrical dangers, such as sharp edges, mechanical moving parts. And it should provide suitable insulation to protect from electrical contact. Mechanical influences, non-mechanical influences. So mechanical requirements, it means that, well, let's say the case should be made like that you are not able to put your finger in to the fan, to the moving part, right? Non-mechanical influences are chemical, let's say, or other influences to your health or to health of animals and environment. Load conditions. Well, overload means that, for example, I have this drill here, I can hold it here and I will overload it, right? And then, of course, it could burn, right? So the overloading condition means that it should still be safe. It can fail, but it should not burn and kill you, right? So this is the low voltage directive. So as you've seen, it's not just about voltages. The low voltage directive is the safety directive, and it's talking about electrical hazard, but also much more. High temperature, explosions, mechanical issues, environmental issues, chemical issues, and all that. So everything that does with safety. What about radio? That's the third directive, radio equipment directive. It's talking about everything that contains radio. That means as a transmitter or receiver, or both. And radio combinations, as I said, could be unidirectional or bidirectional, and also radio determination, such as speed meters or GPS. They have receiver, and these are all covered in this directive. That's quite new, because in the old directive only the transmitters were included, not the receivers. Now in this new radio equipment directive, everything is included that can intentionally radiate or intentionally receive radio signals. So if we are comparing those two, we would say that EMC directive is talking about unintentional radiation of devices, and radio equipment directive is talking about intentional radiative and receiving devices. So what it does not cover is the wired telecommunication equipment with cables, radio amateurs, and other equipment that falls into jurisdiction of other directives. And at the end, again, custom-built evaluation kits here. So, what are the essential requirements? Essential requirements are that it has to comply also to low voltage and EMC. Wow! Now everything that has a radio receiver or transmitter also has to be safe in every aspect. So it has to comply with low voltage and also EMC. Now pay attention. Low voltage directive is covering everything from 50 volts to 1000 volts AC. Now, if you buy something that is powered from the battery, like remote control, with a radio transmitter, it's powered by battery, let's say 3 volts. So it's not a part of the low voltage directive. But since it contains radio transmitter, it falls under radiation or the radio equipment. And because of that, it also has to be tested for safety. Now, what is the reason for that? The reason for that is that lately a lot of different electronic gadgets came from China and other areas as well. I mean, they are really gaining on popularity, and these gadgets contain batteries. And batteries are one of the, most dangerous parts of these devices. And therefore, they said, okay, if it contains a radio transmitter, receiver, transmitter, then it might be also powered by a battery. And therefore, it should comply also with the low voltage directive. About EMC, it's quite normal. I mean, an intentional transmitter can also transmit unintentionally. So it should be covered, or it should comply to the EMC. But the low voltage, that's not that clear. Okay. The radio equipment should be constructed in a way that it does not interfere with the others, and it uses the electromagnetic spectrum very wisely, very efficiently. So it does not radiate more than absolutely necessary for its basic operation. So what is radio equipment? And what are the essential requirements for the radio equipment? Well, it should interwork with all accessories and each other. And here we have common chargers. Now the USB plug for charging phone is now in the jurisdiction, USB or Lightning. So no more 100 chargers for 100 different phones. It should interwork with other radio equipment, of course. Should be compatible or connected to the interfaces according the whole union or world. Should not harm the network. So the mobile phone should not jam the network for the rest of the people if misuse of network, or if it functions, I would say if it goes crazy. All the safeguards should be included in this radio equipment for personal data and privacy. It should also ensure protection from fraud, let's say fingerprints, PIN codes and stuff. Emergency services should be accessible. You should call police even if the phone is locked, right? And it should have also some features for disabled people. And it should allow that the software you load to it, if you download apps, these apps or the system should be made in the way, whatever you do with the app, it should not, with combination of that equipment, cause that piece harmful to the network. So in any way, if you download code, if you use it properly, not hacking, it should be still safe to use. So there are 3 examples here following, because how to say, when we developed electronics, we usually add a lot of these wireless interfaces, and in this field there are many different ways to do that, and I've shown the 3 most common. So first, you can buy a radio interface, a radio module, which is not an apparatus. How to say? The radio module which is not intended for the end user, but is intended for different manufacturers to be used as a component. And radio directive does not apply for that module because it's not intended for end user. It's not required to wear a CE mark. But if you use such a module and you apply it to your product, then you are the producer of the radio equipment and you have to be responsible for the assessment of the conformity, and you have to do everything. Even though you have the results, measurement results from the manufacturer of this module, you still have to repeat all the measurements because these results may not be certified. It does not have a CE mark. Well, you can, on the other side, of course, buy something that is intended for the end user. That would be, let's say, a communication card or a USB communication key. That's intended for end user. You can buy it in Spar, maybe. And these modules should comply to everything regarding the radio equipment directives. So this should be already subject to all the testing by the manufacturer in all different ways. So if you buy such a component, you can use it in your final device without any additional testing more than the basics that is needed for the whole device. Because these already have CE mark and are intended for the end user, so they have to have everything already if they are put in the market. Now the third option is that you buy a module that is not intended for end user, but it has a CE mark. It is already certified. This is usually a little bit expensive option than the first one, but since this one has already all the certificates, you can use it directly in your final product, but you still have to do the essential testing. So it's not like, okay, I use this product, it has a CE mark, it has all the measurement, it has all the certificate, I don't care about it. Not anymore. Because you can, deliberately or not, use it in a wrong way. Because it doesn't have a standard USB plug where you cannot make any mistakes, just plug it in. But here, you can maybe forget to put some capacitors where they should be, or you did not route your lines correctly. And therefore, you misuse or you use this product in a wrong way. And therefore, you need to have a certain testing at the end. But it's not that rigorous as in the first case. So it will cost you less. It depends what you want. If you want to be, or let's say, if you have high volume production, really high volume, then the initial cost of testing will not be that much regarding the cost, the lower cost of the device at the end. In that case, you should take the first option, non-certified module, or even make your own. That's the same thing, more or less. You can make your own wireless interface everything from scratch, and you would have to do the same amount of conformity testing. The other option is, of course, getting a certified module that already has all the tests. It's expensive, but then you can do less testing before the production, and for lower quantity production, maybe that pays off. All right, let's go to the last part. The last part of the talk is the RoHS directive, the restriction of hazardous substances. It's mandatory from the 1st July of 2006, and it regulates the lead, mercury, cadmium, chromium, and some biphenyls and diphenyls. Now, there is also a list of substances of very high concern, which are then candidates to get on that list of RoHS list. So, what is included in this? Household appliances, large and small, IT, consumer, lighting, electrical tools, toys, medical, monitoring, control instruments, and anything else. Well, that's strange, huh? You're very specific, and then you say everything else. But that's what is written in the directive. Well, the more important is, or interesting, what it does not cover. Army, munition. You have lead there. You cannot make a bullet without lead, right? You can use maybe uranium for that, would be even worse. Equipment designed to be sent into space satellites, where the high reliability is of the best concern. Large fixed industrial tools, very fixed and then not disposed by anyone. I mean, disposed controllably. Transport of personal goods, and machinery, heavy machinery. Active implantable medical devices, where high reliability again is of importance, or batteries. Photovoltaic panels, they have to last for 50 years. They have 30 years warranty. So lead is used for soldering, or cadmium even. And again, this equipment for research and development to push the frontiers in science and technology. So mercury is still allowed in lamps. Lead is still allowed in glass, some type of glass, and in some alloys. In solders, it is allowed in servers, in storage systems, or the network, or such equipment that requires high reliability. Special solders as well. Some essential compounds of some ceramics, some inks and weights are also containing lead. And of course, shielding of ionized radiation. Well, you know that lead is good shield from the ionizing X-rays, for example. Cadmium is used in thermal fuses and electrical contacts, and in some LEDs and solar cells. So, we are now at the end, and what are the intended learning outcomes of this lecture, and they are shown at the end here. So you should be able to explain the essence of this individual EU directive related to the electronic products. So you should know what are the components, or what are the, which electronics or which products are falling under jurisdiction of the low voltage or EMC or radio equipment. And we will, let's say, you will have to, if you look at the product, you will have to define, okay, this or this or this falls under this jurisdiction. And of course, for that, you will have to go through this process of eliminating and asking the right questions, as we did with a few products here, like the drill and battery and so on.